Hello guys, welcome back to our channel. Today we having the topic traffic light controller, which had included DDCO, DSA and operating system. We are doing mini project on traffic light controller with real-time OS and linked list management. First we will know the introduction part, in which first we use digital design, like we constructed circuits for traffic lights, and which included microcontroller for simulating the traffic light, and we used linked list data structure to store and manage the traffic light, and also we used a real time operating system, which will be switching the light green, yellow, red based on the traffic conditions. And the working of our model is, first we had fixed three lights, that is green for 3 seconds, yellow for 1 second, and the rest will be red. This sequence repeats for traffic light. There are two interrupts which we added. First one is emergency vehicle. If we press the emergency button, if any emergency vehicle is coming in that route, if we press the button, all the traffic light turn into red except one, which will be green for 6 seconds. It has high priority than the pedestrian event, which is furthermore topic of our project. This event cannot be interrupted by pedestrian interrupt, helps in quick emergency response. And the next one is pedestrian button. If we press the pedestrian button, all traffic lights turn into red for 4 seconds. This has lower priority than the emergency vehicle. This event can be interrupted by emergency vehicle interrupt, helps to reduce the chances of accident. The next will be explained by Ananya.
Hello, now I shall explain about the hardware used in our project. For this project we have used an Arduino Uno microcontroller, red, green, yellow LED bulbs for each traffic light, two push buttons to simulate emergency vehicle and pedestrian event, a breadboard and resistors of 220 ohms to prevent overloading of the LEDs. This is a model of our project. I shall show the demonstration of this project.
Hello everyone, I am Ananya and I shall be demonstrating our model. As you can see, green light lasts for 3 seconds and yellow light lasts for 1 second and then turns red, while the next traffic light turns green for 3 seconds, and this lighting sequence repeats. Here I have two interrupt buttons. One is a button for emergency vehicles such as ambulance or police cars, and one is a pedestrian button. This is to simulate real life emergencies and interrupts for traffic light lighting sequences. When I press the emergency vehicle button, it handles this interrupt by turning all traffic lights red except one traffic light as green. This is to allow quick emergency response. This interrupt handling lasts for 6 seconds. Now, if I press the pedestrian button, all traffic lights turn red. This decreases the chances for accidents. The emergency interrupt has higher priority than pedestrian interrupt. Let me demonstrate this. If I press the pedestrian interrupt, then immediately press the emergency interrupt, it immediately handles the emergency vehicle interrupt. However, if I have if the system is handling the emergency vehicle interrupt, the pedestrian interrupt handling does not occur if I press the button.
Hello everyone. Today I'm going to explain about the traffic light signals scope. This model has a potential to be integrated in street in real life. An emergency interrupt and pedestrian interrupt can be integrated into each traffic light. For emergency vehicle detection, we can use our RFID technology or infrared sensor. Ambulance and police vehicle can have a infrared or radio transmitter which can be turned on during emergencies, and the traffic light can be fitted an infrared or radio receiver. We can also GPS and vehicle to infrastructure communication system. This model design is flexible and can be used in three-way intersectional as well. Model benefit, first of all, first one, traffic efficiency, ensure smooth traffic flow and intersection. Second one is emergency handling, potentialize emergency vehicle and improving response time for ambulance or fire trucks. Pedestrian safety includes a button for safe crossing, making the system user friendly can safe for all. Fourth one is scalability. It can be expanded to larger intersection or integrated with smart city system in future. Fifth one is cost effective, um, utilizes affordable components like the Arduino Uno, making it accessible for prototyping and real world application.